Hello everyone. So today we are going to have a lecture about the transportation modes. Let me share the slides with you so that it's easier for us to follow the lectures. Share screen. Okay. So this is the transportation modes lecture by Dr. Binh from Credit International. So we are talking about the diversity of the transport modes. So for the diversity, currently we have 5 types of transportation. Firstly, the road transportation. Second, the rail transportation and pipelines. Thirdly, the maritime transportation. Fourth, the air transportation. And lastly, the intermodal transportation. So for the transportation modes, typically they are characterized by a set of technical, operation, and commercial characteristics. So technical characteristics relates to attributes such as the speed, the capacity, and the motive technology. While the operational characteristics will show that in a context which modes to operate, including the speed limits, safety conditions, and operating hours. And thirdly, for the commercial aspect, the demand for transport and the ownership of modes are dominant commercial characteristics, as transport modes are used to support the economic activities and generate an income for an organization. So here I will explain to you about the road transportation. So you see the pictures here can illustrate what is the road transportation already. So you see a van, a truck is driving on the road, right? Here you see that the road infrastructures. So you see in the right image, you have the road infrastructure, and often these road infrastructures are large consumers of space and with the lowest level of physical constraint among the transportation modes. And second, you have the physiographical constraints. That means physiographical constraints are significant in road construction with substantial additional costs to overcome features such as rivers and rock terrain. And you know, because it's often incur the highly cost to build the road across the river or any rock terrain. It's very difficult and costly. And you can see that the road transportation in history was developed to support non-motorized forms of transportation. For example, like walking, domestic animals, and cycling at the end of the 19th century. But now, in the 20th century, it is motorization, and that has shaped most of its development since the 19th century. And the road transportation has average operational flexibility, as vehicles can serve several purposes but can rarely operate outside the roads. And road transportation systems have high maintenance costs both for the vehicle and infrastructure, and which related to love lifespan, you can see here. And there are many linked to light industry and freight distribution. Why? Because rapid movement of freight in small batches are the key freight to transport with the roads. And with containerization, this is a link in the freight distribution between the ports and the commercial hinterlands. And second, we will mention about rail transportation and pipelines. For the railways, so railways are composed of a trace path on which the wheel vehicles are bound. And in light of recent technological development, the rail transportation also includes the monorails and the maglev. So they have an average level of physical constraints and upload gradients required, particularly for freight. And often, the heavy industry are traditionally linked with the rail transport systems. Although containerizations has improved the flexibility of the rail transportation by linking it with the roads and the maritime modes. Rails is by far the land transportation mode offering the highest capacity with 23,000 tons fully loaded on a con-unit train. Next, we move on to the pipelines section. The pipelines transportation, okay? So you may know that the pipelines routes are practically unlimited as they can be laid on land or underwater. Their purpose is to move liquids as petroleum products over long distances since the cost-effective versions. So the physical constraints are low and include the landscapes of partially zoned in Arctic environments. Pipelines constructions costs vary according to the diameters and increase proportionally with the distance and with the viscosity of fluids. So it means from low viscosity gas to high viscosity oil. The pipeline terminals are essential since they correspond to refineries and harbors. Here you have some examples of pipelines. So the longest gas pipelines links Alberta to Sarnia in Canada with a length of 2,911 kilometers. The second, the longest oil pipelines is the Trans-Siberian, extending 9,344 kilometers from the Russian Arctic oil fields in eastern Siberia to Western Europe. And another pipeline is the Trans-Alaskan. It is around 1,300 kilometers long, above the ground for most of its path. For maritime transportations, so you know that with physical properties such as buoyancy and limited friction, maritime transportation is the most effective mode to move large quantities of cargo over long distances. Main maritime routes are composed of oceans, coasts, seas, lakes, rivers, and channels. However, due to the location of economic activities, maritime circulation takes place on specific parts of the maritime space, particularly over the North Atlantic and the North Pacific. The construction of channels, locks, and dredging are attempting to facilitate maritime circulation by reducing its discontinuity. But such endeavors are highly expensive. In maritime transportation, has high terminal costs since port infrastructures are among the most expensive to build, maintain, and operate. This high cost also relates to maritime shipping, where the construction, operation, and maintenance of ships is capital intensive. More than any other mode, maritime transportation is linked to heavy industries such as steel and petrochemical facilities adjacent to port sites. And even with the containerization, and maritime shipping has become the linchpin of globalization, allowing trading a wide range of goods and commodities around the world. And the next transportation mode is the air transportation. See, so air routes are practically unlimited too, but they are denser over the North Atlantic, inside North America, Europe, and over the North Pacific. And air transport contracts are multi-dimensional and include the site, such as a commercial plane needs around 3,300 meters of runway for landing and takeoff. So there are other constraints also, such as the climate, the faults, and the aerial clearance. And air activities are linked to tertiary and quaternary sectors, and notably in the finance and tourism, which lean on the long-distance mobility of people. And more recently, air transportation has been accommodating growing quantities of high-value freight and is playing an increasing role in global logistics. And the last transportation mode is the intermodal. So here you will see the picture on the right side. Intermodalism concerns a variety of modes used in combination so that the respective advantages of each mode are advantages. So you see in the right side, the picture, see that it's the combination of the air, the ships, and the truck, the van for the containerization. And other intermodal transportations applies to passenger movements, such as using a different interconnected modes of public transit system. This is overfreight transportation that's more significant impacts of intermodalism have been observed. So containerization has been a powerful vector of intermodal integration, enabling the maritime and land transportation system to interconnect. So this lecture is referred to the Geography of Transportation book, the 5th edition, where the author is Professor Dr. Tran in New York. And thank you very much for your attention. And we hope to see you in the next lecture. Thank you. Bye-bye.